I used to be frightened of getting on airplanes. Takeoffs and landings were, of course, stressful, but turbulence really used to scare the shit out of me. But then I got over it. I got over it by learning more about airplanes and air travel and why turbulence happens. My curiosity became my biggest weapon. If you've been on the internet even once over the last 2 or 3 years, then you've probably heard of AI. It's hard to believe that just about 2 decades ago, AI was a dirty word. Scientists and researchers who were working on AI did not want to tell other people because you were looked at like batshit crazy mad scientists, trying to build like a Frankenstein. Fast forward to today, AI is not just mainstream, it's also cool to be a part of it. But wait, before we talk about AI today, we need to understand how we got here in the first place. So let's talk about that. We've been here before. This wave of optimism around AI, the world's best minds working together to come up with superhuman intelligence, this has happened before. In fact, AI has gone through precisely 2 of these cycles previously. The first one came somewhere around 1950s and was known as the golden era of AI. Towards the end of last World War, we started seeing the emergence of the idea of complex general purpose computers. From mechanical gears, we had arrived to vacuum tubes. England had just won the war and cracked German code, or the Enigma. And not just saved 2 to 4 years of war, but millions of lives along with it. Among the team of young mathematicians and engineers was Alan Turing. This man of merely 38 eventually went on to write a landmark piece of research paper, at the core of which was a question: can machines think? To keep it as focused and sharp as possible, he proposed what he called the imitation game. In essence, he argued that an intelligent machine should be able to fool an interrogator that it's human purely by how naturally and smartly it responds to natural language. Also known as the Turing test, this spearheaded research into the field of computation and building of intelligent systems. I always thought that AI was actually a branch of computer science that eventually sort of came out of the research that was happening eventually and all the compute that was growing. But indeed, this was not a separate system. In fact, these folks envisioned the modern computing systems to be intelligent machines that could think. All efforts into building intelligent systems began, and the best minds in the world went to work. But they all didn't take the same route. See, there were primarily 2 distinct ideologies. One was to build a strict rule-based system, one that could be programmed to do calculations and that can eventually be scaled to perform a wide array of functions. The other one was to build an adaptive system, one that learns like a child, corrects itself, and figures out outputs and answers on its own. As time went on, rule-based systems really seemed to work pretty well. At its core, it required 2 fundamental things: the ability to remember the rules, even as they went from 10 rules to 10,000, and secondly, the ability to process inputs based on these rules, or compute power. Learning system required a lot more time and a lot more data, which meant that it of course required compute, but also required a large data set to be trained on. It's like teaching someone to cook. On one hand, you could, let's say, hand out a book of 50 recipes and have this person learn each of those recipes and cook precisely with the measurements within those recipes. And you'll have someone who can cook 50 dishes. But if anything goes wrong, anything that is not part of the recipe book, anything burns, everything overcooks, something does not necessarily rise up, the person does not know what to do because there is a set of rules that they were following. The other way is to have that person try to cook 500 dishes over and over and over again and learn from their own mistakes and make up their own rules. Well, what that meant is that while they would be able to cook those 500 dishes, anything outside that would also be possible because now they've learned the fundamentals and understood the core of how cooking works. Now, while learning systems did seem to be more promising in building more intelligent systems, they didn't necessarily have the kind of algorithms, the kind of compute power, or even learning data set for it. Hence, rule-based systems ruled. Research also hit a brick wall when they realized that making one general purpose system was not enough. In trying to simulate a simple task of building blocks that children play with, the amount of programming and compute required to build such a system would take years if not decades. So it was clear that this is not going to be easy. To add to that, compute power was a joke. The most powerful processor at the time had as much power as a modern microwave. Moreover, there was also dearth of data. So from the claims of attaining human-level intelligence within a few years, AI became a science fiction project with no real-world use. Funding dried up, governments pulled out of projects, researchers fled the field to other disciplines, and we had the first AI winter. AI became a dirty word, and being associated with it became undesirable. During the 1980s, we saw some interest rise again with some innovations like backpropagation coming into this field. This was a method that allowed AI to actually learn from its mistakes. While this meant that you could build a system that showcased real learning abilities, compute was still a problem. And because businesses didn't see much use, AI went through another lull period.
As soon as I learned to type Amazon.com, I could get my way to about 2,500,000 books. So it was remarkably easy.
I can look up such as Mediterranean cooking, and I find 57 books on the subject.
Instead of standing in line, I just sit here and punch one button and my book's on the way.
The IT revolution will create over 1 million new jobs in the next year, and tech skills can help you get one.
CD Now is music your way, with more albums than any other music store, online or off. And now get up to 30% off store-wide, plus free shipping.
Go online at work or while working at home? Next time you're on the internet, go to the new Netscape.com. Faster searches, instant messaging, a customized start page. The new Netscape. Power and ease of use. It's free at Netscape.com.
Towards the turn of the century, as compute power grew, AI research did pick up, albeit in the shadow of the internet and digital boom. But something else started to change. With the internet boom and the democratization of personal and portable computers, the second part of that puzzle started getting solved. Suddenly, there was availability of data like never before. Texts, images, videos, books, research papers, everything started turning digital. And then came 2012, that I believe was a monumental moment in the history of AI. A professor, along with two of his students, entered a competition called the ImageNet. This was a competition to build an intelligent system that could correctly classify images. There was a training data set of about 1.2 million labeled images. Now, the system that they built was called AlexNet, and it did something different than the previous systems that came on. Instead of using CPUs, AlexNet used GPUs. GPUs were generally used for graphic needs, but for parallel multi-layered learning, GPUs fit perfectly. AlexNet broke benchmarks with a big lead over other competitors in other systems, and this really changed the way people thought of AI and thought of compute. Suddenly, GPUs became mainstream for AI research and training, and you could see compute really opening up. AI was finally back from the dead, and this time for good. Soon we started seeing AI surpassing human performance in certain aspects. Microsoft's ResNet won the ImageNet competition with a 3.6% error rate, better than human-level image classification that's about at a 5% error rate. DeepMind's AlphaGo defeated Go champion Lee Sedol, proving that AI could master complex intuition-based tasks. In 2015, Tesla introduced Autopilot, an AI-driven self-driving system that used deep learning for real-world navigation. Google Assistant and Amazon Alexa AI-powered voice assistants became mainstream, demonstrating AI's ability to understand and respond to natural language. And many of you might remember Google Duplex, Google's AI that made human-like phone calls, booking reservations convincingly. So AI started to become part of everyday life. While there were other landmark innovations later on like transformers that really make the base of most modern AI that you use, I believe the real masterstroke was OpenAI's GPT-3 being open to the public, and I believe that helped achieve AI escape velocity. Today, many of us actively use AI through our workloads, and it's not going away. We are only going to use more and more tools as we move forward. And many things as we've known will change, because finally there are real-world advantages that these tools bring. This speaks to the timing of things. What early researchers thought about AI, thought about these systems were not actually too far off. The only thing was the ecosystem necessarily did not exist then. Neither did the compute power exist, neither did dataset exist. And that speaks to the timing of now, and now being an important time for AI to really shine and grow. Today, there are about 4 to 5 billion smartphone users in the world. This means that more than half of the world has supercomputers in their pockets, And these supercomputers with the power of internet are connected to mega supercomputers on the cloud. AI couldn't have had a better time than this to come out of the closet. That being said, are we anywhere close to human level intelligence? Well, I don't think that's the case. Let's try to imagine a human being with the capabilities of AI today. This would be a person who's extremely hyper intelligent in certain aspects, very forgetful, might not even remember what we talked about an hour ago and might need context with every conversation. Extremely overconfident even in wrong answers. Socially awkward and little to no common sense. So they'd be amazing at trivia nights, terrible at deep conversations, and almost completely lost in real life. So, you're probably watching this video on one of your supercomputers. And with the internet, you have instant access to AI. So now what? What do? You know, my fear of airplanes turned out to be just a fear of the unknown. And that's something many of us experience whenever a groundbreaking technology emerges. It happened with books, it happened with the television, it happened again with computers, and now it's happening with AI. But here's the simple truth. The best way to overcome fear or confusion around new technology is to be curious, to ask more questions, to fiddle around. Today, it's AI, tomorrow, it'll be something else. And if you haven't already noticed, technology moves at an incredibly fast pace, and ignoring it or dismissing it won't slow things down or make it disappear. So embrace it, play around. Poke at it from different angles and see what comes out, and then poke some more. You see, Alan Turing's question of can machines think led to 70 plus years of research, AI, everything that you see now, and so much more that's going to come. So who knows what yours might lead to.